This video, we're going to talk about percent change. So percent change is going to be final minus initial divided by initial. Times 100%, which is the same thing as 1, but we change it to a percent. So we find the amount of increase, which is the final minus the initial. And so they're going to call it amount of increase or decrease divided by the original amount. That's another way to look at the formula. So I have a table here for my first problem, which is like section 5.6, number 37. I'm also going to do one like 5.6, number 41. So my original amount is $200. Then the new amount is $280. We're going to find the amount of increase. And we're going to find the percent increase. The amount of increase is 280 minus 200 is 80. That's my amount of change, and my percent change, my percent of increase, is going to be the amount of change, 80, over the original amount, 200. I'm going to make that have a denominator of 100 by dividing top and bottom by 2. And since that's written over 100 right now, that is a percentage, so this is 40%. The other thing that I could do is I could do long division. And I could get a decimal and then move the decimal point 2 places to the right and add a percent sign. So this is going to be a 40% increase. Now I'm going to go ahead and clear the screen so I can do the next problem, which is going to be a percent decrease problem. This one's going to be like 5.6, number 41. Let's put these numbers up here again because I think that I missed a couple of them. 45, 47, and I think 57 as well. All right. This one's also a table. And original amount was 20. New amount is 5. Amount of decrease, percent of decrease. So the amount of decrease is the difference here. 20 minus 5 is 15. And the percent decrease is going to be the amount of increase divided by the original. Now, I can multiply 20 by 5 to get to 100. That's going to give me 75 over 100 is 75%. I also could take 20 into 15 Let's reduce this first. They're both divisible by 5, so this is 3/4. I think you know that 3/4 is 75 hundredths or 75%. But if we did not know 3/4 as a decimal, we could do long division. And 4 does not go into 3, but it goes into 37 times, which is 28. Subtract and get a 2, bring down the 0. 4 goes into 25 times, and my exact answer is 75 hundredths. We move the decimal place 2 places to the right and add a percent sign. Now, we're always stating this as a positive number here, but you could always use the formula that if you take the new number, the new amount minus the original amount over the original amount, if it comes out to be a negative answer, then that's a percent decrease. If you end up with a positive answer for that formula, then it's a percent increase. And that's how we do it in science a lot, is that we will express any percent decrease. We'll just express it as a percent change, and we'll use a positive value for a percent increase and a negative value for a percent decrease. So we haven't talked about negative percentages right now, but this would be a case where a negative sign would mean that I'm losing something from the original amount as opposed to gaining something from my original amount, which would be a positive value. All right. There are 152 calories in a cup of whole milk and only 76 in a cup of skim milk. So whole milk is going to be 152 calories. And skim milk is only 76 calories. Find the percent of decrease in the number of calories per cup. So this means that I would have wanted this difference if I did final minus initial or new minus original. I would have wanted a negative value. So it means that this is my original or my reference value. And this is my new or experimental value. Reference value can also be a theoretical value, and that we are trying to hit that target. In science, this is what we get when we run our experiment lots of times. But anyways, we're going to say that this is 76 minus 152 over, I'm going to put that in absolute value bars so that we make it a positive number, over the reference value here of 152 times 100%. So that numerator is the same thing as 152 minus 76, since 152 is the bigger number, divided by 152 times 100%. So that's going to be 12 minus 6 is 6, 14 minus 7 is 7. So there's twice as many calories in whole milk as skim milk, according to this problem. So 76 goes into 76 one time and into 152 two times 100%. We know that 1/2 can be written as a decimal. 0.5 or 0.50 times 100%, and there was a 50% decrease because there's half as many calories in the skim milk as there are in the whole milk. So that was like number 45 in the textbook. Now let's look at one that's like number 47. The number of cable TV systems recently decreased from 13,900, that's my reference value, to 13,660 is my new value. Find the percent decrease. So we'll find the change divided by the original, but the original needs to go on the bottom here. And we need 13,900 minus 13,660. 0 minus 0, 0. 10 minus 6 is 4. 8 minus 6 is 2. This is going to be 240 over 13,900 times 100%. So let's go ahead and try and turn this into a decimal. I'm going to go ahead and use my calculator to do that. To 40 divided by 13,900. I get a lot of numbers. It doesn't come out evenly. And my instructions here tell me to round to the nearest tenth of a percent as needed. So I'm going to go out to the thousandths place value. So this is going to be 1 7/10 of a percent. And this is, remember, this is a decrease because we're not using signs, positive and negative signs, to indicate increase and decrease. We need to say that it's a percent decrease. All right, let's look at one more problem. A region's average movie theater ticket price in 2007 was $6.68. For 2017, which is 10 years later, it was estimated to be, just a second, $8.24. Find the percent increase in the average movie theater ticket price for this 10-year period. So we're going to take the new value, which is higher, minus the old value, which is lower, divided by the old value, and 14 minus 8 is 6. 11 minus 6 is 5. 7 minus 6 is 1. Those are units that are going to cancel. I'm going to use my calculator again to figure out what this is. 156. 1 5600ths, that is, divided by 6 6800ths. And we're again rounding this to the nearest tenth of a percent. So we're going to take this out to the hundredths place. It's approximately equal to 234 thousandths, excuse me. We're going to take it to the thousandths place. And that makes this a 23.4% increase. All right, that's it. Next time we are going to talk about calculating sales tax, which is a markup. It's an application of what's called a markup. You have a similar thing called a markdown, which is when something goes on sale, but sales tax is always in addition to the regular advertised price. So it's always a markup. All right, we'll talk about that next time. See you for that next video.